I am Praveen Reddy. So in this today's session we are going to learn about the distance vector routing. So to understand that, first we need to understand the what is the functions of the network layer. So the main function of the network layer is that to find out the shortest path between your node to another node, nothing but one router to the another router. So to find out the shortest path we require something called as the database or routing table. Right, so based on that routing table only it is going to find out the shortest path in router. Now to have the routing protocol, so what we have to do means we have the two things. One is intra, another one is inter. In intra we have the same autonomous system that is called as the intra. Inter means so one autonomous system to the another autonomous system, that is called as the inter-domain routing protocol. So we are going to discuss DVR protocol, which is based on the intra-domain. It means that same autonomous system. So here we are going to see exactly how the operation of DVR going to perform. So first one point to remember is that here in this, that what is the meaning of the vector. So the simple meaning of vector here is that it is going to have the table. The meaning of the vector is table. So right, each router or node will be having the something called as the table with respect to its distance to the other router. So see that it maintains a vector table of minimum distance to every node. So based on that it is going to find out the shortest path. So based on this it is going to find out the shortest path. So every router will be having the routing table in terms of the distance. So based on that it is going to find out the shortest path in case of the distance vector. So to understand this algorithm we have to remember that two important points. The point number one is that what is the meaning of routing only to the neighbors. Right, the router sends its acknowledgement about the network to only those routers which have the direct link. Now we will understand what is the meaning of this one. If you see here, so it is sharing its knowledge, nothing but knowledge means it table is nothing but the vector, to only those router which have directly connected. Now we will see understand what is the meaning of directly connected. So I am going to consider ABCD are the nodes or router. So I am going to give the connection A to B, A to D, and B to C, D to C. Now if you observe here, if I take the router A, so directly connected is what? B. For router A, directly connected is what? D. So it means that it will exchange routing table to only D as well as the one more is B. So it will not exchange it routing table to the C because it is not directly connected. Right, it will not exchange routing table to C because it is not directly connected. See that in diagram also A is directly connected B as well as D as well as D. C. So for this only it is going to exchange, for E it is not going to exchange its routing table. That is the meaning of neighbors. Now see that at every 30 seconds it is going to exchange its routing table to the neighboring router. Remember the very important point is that it is going to share its neighboring router. It means that only directly connected nodes are routers. Right, so that point you need to remember. Now first what you have to do means that first we need to perform the initialization operation, and each node or router will be having first initialization database. Suppose for see that here we have the table for the A. Right, we have the three columns: to address, what is the cost, what is the next hop ID for router A. And what is the meaning of this one is from A to source is A, destination nothing but the to address. Either you can go to B, C, D, E. So what is the distance or cost or number of routers, we can tell the cost. So from A to A the number of routers involved is 0. It is directly connected means dash means directly connected. Right, it means that directly connected means direct connection, no, not required of the next hop. So A to B distance is 5, C distance is 2, D distance is 3. Right, so see that in the diagram as shown that. So everything here, if you observe here, we have the next hop ID dash is there, right? It is means that it is directly connected. It means that it can reach to the another node directly without helping another. Now if you see that from A to E, it does not know how to go because it is not directly connected. This is very important point to be understand. So if you want to go to E, there is no direct connection. So this is what we called as the unknown router or unknown node for A. It means that we need to write routing table infinite. We don't know next hop ID also at this point of time, so it is empty. So like this each table it is having the initialization steps or initialization process. Right, so it means that it will be having the only directly connected path for each node or each router in the network. That point you need to understand. So now we'll see that procedure. So based on the DVR procedure, how it is going to find out the shortest path, that we are going to see now. The first step is that it is going to initialization of table in distance vector routing. Remember, the important point is that in initialization process, it will update only directly connected table. Suppose for example, see 2 cast next up ID is there, right? These 3 columns, every router is going to update it. See that you can observe from this diagram, each router or node having its initialization routing table. That is the first step. For example, if you consider this C, if it want to go to A, the distance is 2. It is directly connected, right? Dash means directly connected. Now to go to B, the distance is 4. As you can see in diagram, to go to C itself means 0. Then if you see that, if it is want to go to the D, the distance is infinite because it is not directly connected at this point of time, we don't know. For E, it is 4. That is what we called as the initialization process. Now it means that after doing the initialization step, it is not the final updated table or shortest path. That very important point you need to understand. At initialization, it will know the table or database of the only directly connected router. In case of A, it does not know how to go to the E. But final table, A should know everything. So for that, what we have to do is step 1 is completed. Now we need to learn the step 2. So the meaning of step 2 is that it is going to share its distance vector routing to its neighbor. So remember that neighbor means it is directly connected routers. See, for example, the router will exchange its database to only to the neighboring routers A to B, A to C, A to D. It will not share its routing table to the E. That is the point to be remembered. The same way, right? So C share its routing table what? Only A as well as the B as well as the E. It will not share its routing table to the D because it is not directly connected. That is important point to be remembered. So now question is that why we need to share our routing table to your neighbors. For example, suppose C, A does not know how to reach to the E, right? Because it is not directly connected. But C, if you understand, C knows how to connect it to the or how to reach to the E, right? If somehow C is going to update its routing table to the A because C know how to go to E, right? If somehow C is going to update its routing table to the A, then it can learn. A can learn. For example, see that C don't know how to go to the D, but A knows how to go to the D, right? Because it is directly connected. If somehow A is share its routing table to the C so that C can get the updated, so C knows how to go to the D. This exact concept we are going to apply here, right? Now you understand what is the need of sharing its routing table to the neighboring router. So based on that, it is going to update its routing table. So it is going to find out the shortest path. Now here in case of the distance vector routing or DVR, one more important point that you need to remember here is that, so in initialization process, each routing table will be having the 3 columns. The first one is to address, nothing but destination. Cast means how many routers in between. Next hop means if you are going anything via, that is next hop address. But when it is sharing, it is not going to share entire routing table to its directly connected or neighboring routers or node. That is the very important point that you need to understand. So out of these 3 columns, 2 cast next hop address, it is going to share only 2 columns. What is that? It is going to share only 2 address as well as the cast. It won't never ever share the next hop ID. This point is very important in case of the DVR routing protocol. Now see that in this diagram you can see that, so C is updating its table to the A in this example. So it is going to share only 2 columns, not the next hop ID. So in case of the DVR, that point you need to understand clearly. So after sharing process is done, now what we have to do is exactly we need to perform something called as the comparison operation. So what is the need of performing the comparison operation means, in order to find out the shortest distance from your source node to the destination nodes. Now exactly how comparison operation going to be done, that we are going to see now. Now for this example, let's C is going to share its database to the A. Remember, C is going to share its database to the A. Now A wants to update its shortest distance. Remember, again I'm repeating, C is going to share its routing table to the A. So now A is going to update its routing table. What are the steps that are involved? That is what exactly we are going to see now. Now see that. So we have here we have something called as the H volt table, right? So in the diagram left mode side, you observe here the left mode side. So we have the H table, right? Initialization table. The table exactly I'm going to write here. This is what we called as H volt table. We can call this also initial table. The same initial table in the leftmost diagram, just here I'm going to write. Now what I'm going to do here is that for time being, I'm going to keep it as aside. For some time, let it be aside for some time. Later on we'll come back to here. Later on I'll explain what is the exact operation will be performed here. Now what we are going to do in step 2 is that C is going to share its routing table to the A. Now here one important point you need to understand here is specifically A will think that I will go via only C. Even if I want to go from A to A also, even it is shortest distance also, I will not go to A to A. I will go everything via C. If you observe here in A's modified table, everything is going via C. So in initialization table, if you understand, so see here meaning, if you want to go A to A also, here from A to C we are going, with the help of C only we are reaching to the router A. See, first it is going to the C with the distance of the 2, then it is reaching to the A. That is the meaning of the C sharing. So remember, one simple point is that now what in the step 2 A is thinking that I'll give all the priority preference to the C. So whichever I have, I'll go via C only. That is the meaning of this one. Now see that received from C, what is the table? 2 column table only we will receive in case of the DVR. Right? Now see that what A is going to perform the modification operation is that everything is going via C, so that if you observe here in yellow color, next up ID is only C. Now for example, suppose always A will go to the C. As per the table in the leftmost side, if you want to go from A to C, what is the distance? 2. That point to be remember. అంటే మీనింగ్ ఏంటంటే సో టు గో టు రైట్ ఫర్ ఎగ్జాంపుల్ సీ దట్ ఇన్ రిసీవ్డ్ ఫ్రమ్ సి టేబుల్ సి ఈస్ టెల్లింగ్ దట్ ఇఫ్ యూ వాంట్ టు గో ఈ ఫ్రమ్ మీ ద డిస్టెన్స్ ఈస్ 2. The distance is 2. Now what is A is thinking that okay, if I go via C, the distance is 2. Now A will go to the C. So already if you want to go to A to C, the distance is 2. Now from C it is taking back to the A. So in the table received from C it is 2, right? So 2 plus 2 equal to 4. In simple meaning you can remember that how to write H modified table means received from C table is there, right? For that you need to add plus 2. Why plus 2 means first initially we are going from A to C, right? Now via C only we are reaching to the all other destination. Simple thing. So if I want to go from C to B, the distance is 4, right? As for the received from C, so plus 2, nothing but in H modified table you are writing the 6. So nothing but 2. First we are going to A to C, that is distance is 2. Then C is telling that to go to the B, the distance is 4. So 2 plus 4 equal to 6. Simple thing, by default you add plus 2 because A to C the distance is 2. Now C is telling that if you want to go to C 0, so it is going to add plus 2, 0 plus 2. Now C is telling that I don't know how to go to the D, so it is just writing the table. So now C is telling that if I want to go to E, just to come to me, the distance is 4. Now it is going to update 2 plus 4. See that here the priority everything will be given in step to the C. Even if it is want to go by itself also, it is not going via C only, it is going. This point you need to remember. If you understand this one, thus A is modified table is nothing. Everything next up ID is C. Now see that we have kept aside, right? That step 1 nothing but A's volt table, right? That A's volt table or initialization table is going to compare with the A's modified table in order to find out the final A's news table. That is what we called as the updated table. So there only we are going to find out the shortest path. Remember that in first step we have the A's initial table, right? That table is going to compare with the A's modified table. So after going to perform the comparison operation, see that. So first one A4C in A's modified table, in volt table A0 dash. So which is the best one? A0 dash, right? That is going to be updated finally. Now see that in second step C is telling that if you want to go to B, my distance is 6. But in A's already initial table, if I want to go to B, distance is 5 and directly connected. So which one is the preferred? Volt table is preferred. So C to C it is C2 dash. So it will update C2 dash. Why? So same distance is same, but here we need to go via C. in case of modified table. But if you observe here, old table or initial table, it is directly connected, so we are going to prefer for the directly connected instead of going via C. That's why it is updated C2 dash. Now see that D infinite C in A's modified table, but here initialization table D3 dash. Now finally see that E infinite, here E6C. So one point to be understand here is that in A's initialization table we don't know how to go to E, but in A's modified table we know how to go to A, right? Sorry, how to go to E, right? So that is what we are going to update it here. Now see that initially we don't know how to go to E, now we know how to go to E. Via C we are going to the E, the cost is 6. This is what exactly updation is going to be done. Based on that it is going to find out the shortest path. So in exam point of view, you no need to take all the comparison, even it is not possible. You take any one comparison, you just explain how it is going to work out effectively. Based on that you find out the updated table, that is more than sufficient. Thank you guys.